Good morning, everybody. So great to be here at NSBCon. I want to thank Udi and the team for inviting me to do a presentation. What I'm going to talk about today is a little bit about what do you do after you have a little proof of concept and you've proven the technology, and let's admit, with NServiceBus and the platform, that's really easy to prove that it works. But then you go back to the office and you're trying to figure out, well, how the heck am I going to get my company to adopt this thing? What am I going to do? Most of us work at places that have lots of brownfield code and lots of preconceived notions about what ESBs are and what they do, and how are we going to go about that? And the way I'm going to do that is I'm going to talk about maybe a half a dozen use cases for my particular company. I'm going to sprinkle in a couple of demonstrations, but my demonstrations are really going to focus in on some of maybe the lesser known features in the platform that we've taken advantage of. I think a lot of the documentation, the samples out there, like we said, have gotten pretty good, so you guys probably know most of the basics, but I think I'm going to try to dip into some other things. So this is who I am. I'm a solution architect at a company called Wegmans Food Markets. It's a regional grocery retailer in the Mid-Atlantic and New England. One of the NServiceBus champs. Where you'll find me the most, though, is right here. Oh, you can't even see that. On Stack Overflow. So I like to hang out here and answer as many questions as I can. So if you ever have a question about the platform, please post it here, and we'll make sure that that gets answered. So back to the slides. Oh, there we go. So the tablescape. So I'm in the food industry, so the idea of a tablescape, much like a landscape, is so that when you're enjoying food, if you don't know, you need to feast with all the five senses, and your eyes is one of those things. So I thought I'd reference the tablescape to give you an idea of where I come from and the environment I'm working in, to maybe draw some similarities with your own environment. So again, we're a regional grocery retailer. We don't just do groceries. We do wine and spirits. We have independent wine stores. We have restaurants that are marketing tools for our stores. So all the products that we carry in our stores are represented in those restaurants. We have 90 plus stores in 6 different states. We have millions of customers. We have a relatively medium to large size IT department for that group, and we have in total roughly 45 to 50,000 employees, but it's only maybe 2,000 or 3,000 of those are actually at the corporate office. So where do we start? I had gone to Udi's class a long time ago, several years ago, and came back and started experimenting, again, doing a proof of concept with some of the technologies and concepts that that he was talking about. And when I started to talk to our internal folks about that, an interesting thing came up. Come to find out, we already owned several like technologies. We already owned things like web methods and WebSphere and all these other things, and I'm sure that's very common in this room. Is you may have a collection of things that do similar things, and that's great, and that's hard to sell, let's say, to a CIO, right? Because he's like, well, look at all this stuff we already have. We're already doing these things, aren't we? But come to find out, the way that we actually really sold this was even though you own these technologies, they're really only point solutions on top of other things you've already bought. So a lot of times a vendor will come in, you have an off-the-shelf application, they say, hey, you need this thing to integrate, you put in that thing, be it web methods or something else, and that's it. It doesn't go any further. It's just that point solution. So we came in and said, hey, what's really enterprise about that? Nothing. You're not really using that technology across the board. So what we said is we're going to come in and we're going to take a look at things from an enterprise view. We're going to look at something that is very developer friendly. We have a pretty decent sized development staff. They're all very familiar with .NET. We're going to look at something that's more .NET specific, and that's where NServiceBus and the platform really came in. The other thing that I would advise you to do is when you're talking to not just your CIO and everyone else internally is make sure you talk to your operations people. One of the biggest challenges we had is our environment was very much batch focused, and everybody's used to running and rerunning these huge monolithic batch jobs, and it's hard to get around that paradigm. It's like, well what are we going to do now? How are we going to do that? So make sure you include those people as part of the conversation. It's really becomes key, and you don't want to do that when you're 90% of the way through the project, right? You don't want to get to the end and say, whew, hey, how are we going to support this thing? You really want to get through all that up front. So how did this really go down for us? The interesting thing was the first project that we did was a greenfield project, which was nice. It's a great opportunity. And we really started using the distributor and some of the load balancing features of the platform. I would say that's probably unusual. Most people aren't looking for that type of functionality out of the box. I will tell a little bit later about the story behind that. Then we got into some more of the, I would call more standard patterns, doing some things point to point, things of that nature. Then we got into pub sub. And then lastly, we really got into workflows and sagas and the true, true power of all that. Again, I think this is somewhat atypical, but this is the path that we particularly took. So our first project was to build an order management system. So this is in the supply chain arena. For those of you who are not familiar with what an order management system does, basically it determines how to best source product. So we need to supply our stores with products, and this thing figures out the best way for it to get there. Now, that could be in one of our warehouses. That could be in a warehouse off-site. That could be from a purchase order that's in flight from a vendor. So there's a lot of optimization that we can do in terms of building that path. So when we take orders on, we really need to sift through all that data relatively quickly in a very, very small window, because the next thing we're going to do is push that to our warehouse management and transportation systems so that we can find the optimal way to transport all that product to the stores. So what we really needed is a system that would take all that data, cram it through all those algorithms, and come out with an answer on the other side in terms of what's the best path. We shopped around for months, lots of different products out there. We looked at things like Sterling, and Manhattan has a product, and all that. But none of them could really do or perform the way we really wanted without some heavy customization and a ridiculous amount of hardware. So we decided that, hey, maybe we should just go off and do this thing on our own. We know our flow paths better than anyone else, and more than likely we would have to customize it. So why don't we go and do that? And the last point here I really want to point out is we had a team of people who were all experienced Power Builder people. So if you haven't heard of Power Builder, it's a very much thick client built upon some heavy database interaction. It's relatively unique. And the impressive thing is not only were these people really converting over into the .NET world, but they're also converting over to NServiceBus and that whole platform. And we were able to pull it off, I would say, relatively easily. So I think that's a testament to the product in and of itself. So let's take a look at the solution for that and how we did this. So where it all starts is order entry. So we have those 90 plus stores, let's say, they're all contributing orders. There could be on order in order of, let's say, 75 to 100,000 orders, and then underneath that, each order has several hundred items. So this gets rather large pretty quickly. So all those orders get dropped into a funnel, all coming in at different times, different ways. And then what we do once we receive those orders is we blow them up. And the reason we blow them up is because we want to take all the different demand for all the different products and aggregate all that together. And it's not just for the items, it's for the stores, what store is closest to the other stores, so on and so forth. They're really trying to optimize where that demand stream is coming from. So then, in order to do that, we did that through a distributor, and we send that off to 1 or 2 workers to figure out the algorithms then of what's the best way to get this to a store. And then all those results are written back to a database, and at the very, very end, we publish that over to 2 places, our warehouse management system and our transportation system. Now, that seems somewhat counterintuitive, but you really want to go to your transportation system first because you want to know how you're going to load your trucks even before you're doing your wave planning in a warehouse management system. But by using the publishing feature in conjunction with this, we were able to do that, all at the same time essentially and optimize that path. So from here, we found, in all actuality, with the distributor, and you may find this too, and I think there is a point of diminishing returns. We run actively right now with 1 distributor and 2 workers, each of them running multi-threaded, but we found that at some point, you reach a cap, and that's really highly dependent on the type of logic that you're really doing in those workers. So it's going to be a little bit different for everybody. So I'm going to go into a demo of this, and again, I'm not going to show production code. I have samples. I'm actually kind of bummed out that yesterday Sam covered some of this, but I'm still going to go through a little bit of it. And the one thing I'm going to add to this is I decided that to make this a little more interesting, I'm going to point Service Insight at this. And what I found is the way it represents itself is a little bit interesting. So we'll see how that looks. All right. So here's our little demo. So what I'm going to show you here is, what's that? Oh, why does that keep happening? Thanks for pointing that out. Ah, there we go. So this is a little fictitious message here. It's not really doing anything. It's just passing some boring things around. Can everybody see that? I tried to make sure that my font was super large. So this is the message type that we're handling around or passing around, and what we're doing is we're just going to build up a bunch of those messages and let the workers handle all that. So in here, I think you guys have probably seen this from the samples. I'm running this, slightly differently than everyone else. I'm running this with the distributor as a standalone. And the reason we did this, or the reason I'm showing this, is before, on earlier versions of NServiceBus, this is the only real option you had. You didn't have the option to, have one of the nodes do work at the same time. So I wanted to set up a situation that's very similar to what we have. So that includes a head here, the distributor head. And this is pretty easy. You put in that profile. The rest of the code is pretty much as is. Same thing with the workers. You identify those with a profile, each one of them being a worker in and of themselves. So if I go into one of these workers, not doing anything particularly interesting here, just printing out some messages, pretending that we're doing some work. One thing that may be of interest in here is, I don't know if people have used this or seen it before, is actually specifying the order of the handlers. So this is something that we've used from time to time where you can say, hey, I want my handlers to go into a specific order. So the way you do that is you implement this I specify message handling order interface. You call that out, and then it has a nice little declarative syntax here. You can say, first do this guy, then the next one, and then the next one, and so on and so forth. So this works really well if you have some kind of logic that you need to kind of do at the beginning and then again at the end. So if you haven't seen that before, that's pretty much how that works. So what I'm going to do is fire this guy up. and you'll see the fantastic spray of console windows. There's worker 1, there's worker 2. So here's the distributor head, and it's actually reporting. I know it's probably hard to see, but what's happening here is all the workers are checking in. It's printing that out, so you can kind of see that. And the way I'm working with this is much like what we did with our project. Is this distributor client is very similar to that order entry piece. So what we've got here is something sending messages into this distributor over here, and then we've got worker 1 and worker 2 going about their business. So we can jam on some messages there. And you can see as it starts to alternate back and forth. Now the one on the left actually has a few more handlers inside of it, so it's running a little bit slower. But as you can see, I mean, that's really simple to get going pretty quickly. And I think when we started down this path, we were like, man, how in the world are we going to scale all that out? How are we going to deal with all those orders, those lines? And with this distributor pattern and just using things right out of the box, that was really easy. So what I'm going to jump over into now is service pulse. So now we can see that I've got some heartbeats going on. I've got my distributor right here. I've got my worker 1, my worker 2. I've even got my distributor client. So in here it sees that there's actually 4 things running. Everything's going great. The interesting thing is when I went over to Service Insight, this is what I saw. And I was a little confused by it at first. I was like, well, I have 4 things running, but this is showing me 1 thing. That's fine. It is showing me that the client is going to a worker. But it's kind of skipping by the fact that there's something in between, and maybe that matters, maybe it doesn't. But what's interesting is if you start to go through these messages, you'll see along the bottom there, it actually does bounce around between worker 1 and worker 2. So in all actuality, it is showing that it's just ping-ponging back and forth. But from a system diagram point of view, we get the one thing going here. So I think that may be some kind of edge case, and maybe it's not even important to see the other things running because you do have them over in service pulse. But I just thought that was interesting, an interesting thing to stumble upon. So that's the distributor demo. I'll head back to our slides. So then what happened from there was pretty interesting. We had really good success with that project. We were able to meet our performance requirements. I think we were able to jam everything through. I think it was in under 10 minutes or so. We had to get everything through that window. Everybody was super happy with that. And I think the biggest sell to a lot of people out there was being able to just replay messages. If you come from a batch-oriented world, it's kind of a scary place because when something fails, you really have to start it over all the way from the beginning. And people really appreciated the idea of, hey, if a few things went wrong, I didn't have to start from the beginning. I could just drop those back in and start to play those all the way through. People really liked that. And then from there, things really started to catch on. So in our supply chains area, it actually grew on from there. It grew into our warehouse management system. So we actually purchased a new warehouse management system, and in all actuality, it actually had a nice HTTP type integration. You could have it call an HTTP endpoint. So we set up an NServiceBus endpoint to allow things to get onto the bus. And we were collecting all those messages that were being passed from that warehouse management system, and we used that as an integration point to all the other systems that we had in our environment. And you can imagine with a warehouse management system, there's a whole ton of those. And then we'll also be able to do that in both directions, data coming in, data coming out. The next area in the supply chain world that this started to take off is right now all of our orders and all of our order entry is really done by people. I'm sure people out there will think, hey, that's pretty crazy that in this day and age, don't you have all that information? You can forecast and do all those things. And you're right, you can absolutely do that, but we haven't really done that necessarily to date. So another area of integration that we've used this for is for something called CAO. It's computer assisted ordering, and what that does is allows people to manage just the inventory. They're not managing orders anymore. And then there's a forecast created based off of all the sales data, the things that are moving in and out of our warehouses, so on and so forth. So the product that we bought actually was installed at the store level. So we've got 90 plus stores, right? And this project isn't totally complete. We had to figure out a way, well, how are we going to shuffle information to and from each store? How are we going to pull that off with so many stores and every year that grows and grows and grows? What are we going to do? The interesting thing about this particular product is that it expected a lot of this data in file formats. So one thing we experimented with is could we use the data bus feature, again, that we saw a little bit of yesterday, to move data back and forth to the stores. Now, the interesting thing about our stores, back to what everyone's been talking about this past couple of days, is the network between these different stores isn't great. It could be as small as a meg all the way up to 3 megs, up to 10 megs, or it could be gone altogether. So we're very conscientious when we build systems, at least where I work, about how much data we're putting over the network to a particular store. So when we started looking at the data bus functionality, we were putting some decent size of files across that, and people were really worried, and including myself, in certain situations that may not work. So what we did is we actually customized that a little bit. And we customized it a little bit at 2 levels using some of the extension points, and I'm going to show you a little bit of that here in a minute. So the first thing we did is we actually did compression at the message level. So we compressed all the messages going back and forth to the different endpoints. Then we actually took over the data bus and started compressing the files. So when we were pushing data back and forth to the stores, we wanted to make sure that was as tiny as possible. So I'm going to go into a demo and show you how we did that. Yeah, same problem again. Thank you. Ah, yes. So just give me a second to jump into that particular solution. All right, so in this particular solution, we have 2 sides. We have a client and a server. The client being the one sending the messages. Nothing particularly wild here. The one thing you do want to know is when we're initializing this thing, we have our own compressed file share data bus, and we have a location for which those files are going to go to. I'm just pushing them right to my local system, but again, this could be a file share across a LAN, across a WAN, wherever it is. This is our own customized piece of configuration. We ended up putting that into a different project altogether because you need to share that between the client and the server projects. So that just became an include. So in order to configure that, we came in and just did a little static class here and set the bus equal to our new file share data bus with that path, registered in that into the container, and then return that configuration back out. So by doing that, you get that nice configuration that we saw over here in the client. So I can just append right on to the normal, I want custom initialization code, and it plugs right in. So that's really the first piece, is just telling the system that you want to take that little bit over. So the next thing I'll go into is the actual compression in and of itself. So this is based on the existing data bus that was already there, but the only thing we really did is we overrode the get and the put methods, and when the streams came in, we actually just used gzip, open up the file, copied that into a smaller stream. Actually, it's on this side, a smaller stream. Wrote that out to the buffer and produce the key back. So it's pretty simple to integrate this code in. It's really just standard, out of the box gzip kind of stuff, and the same thing on the get side. So once that's compressed, gets called on the opposite side, you want to get that out, take the big stream, copy that over, pull that out, and that's pretty much it. There's not much to it. So again, the way we're getting that is off of that iDataBus interface. Pretty straightforward. So then the next thing we did is we said, well, if we're going to compress all the files and everything there, then we might as well compress all the messages as well. So same thing, we're still using gzip. The different interface being used here is we're actually using a message mutator, and we're doing that both on the inbound and the outbound side. So again, as the messages come in, we take that, we zip that up, set a little header here just to let ourselves know that we are actually compressing those. That was just a nice thing for us to add, and the same thing on the way out. So let's take a look at the client side of this. So when the client side fires up, basically when we start, we create a new message. This is a fictitious message that I made up. It's got a property which is just a big old blob. The important thing to note here that property has to be a particular type. It has to be a data bus property. So I'll go over to messages and show that. So when you define this message, and you want something, large on the data bus there, you have to declare it as this data bus property, and it's just a big old byte. So now we have our property. Made a little note here that this is about 5 megs worth of data, and then we can go check out the server side of things. So this is pretty standard server side setup. Again, disabling a couple of features didn't really need for the demonstration. And the other key component is, again, you have to put the configuration piece in there to use this version of the data bus instead of the out-of-the-box version. And then from a handler standpoint, again, we're really not doing anything. We're just proving the point that the payload actually gets compressed in transport. So I'll fire this guy up. Two windows here. We got a client side on the top, server side on the bottom. Again, you'll note here it's spitting out that the data bus is started. Location is C:logs. So I'll hit enter just to send a message over. There it goes. Booyah, right on the other side. So if we go over to our file system here to see what actually happened, created a folder, got a file here with a key, and notice that is nowhere near the 5 megs. So what we saved is a ton of space going over that network. And really, it was pretty simple to do. We took over that data bus, did a little compression on those files, and now we can feel good about the amount of data that we're pushing over that very unreliable network connection with not a ton of bandwidth. Okay, back to the slides. So what do we really take away from that? So in our first voyage into NServiceBus world, people really dug the replaying. That was something that they weren't used to. They're like, wow, this is amazing. I could just take some stuff, take some action, maybe update some configuration, drop those back in, and boom, they go right back around. The other thing to note when you're talking to your operations folks is you do need a certain amount of DevOps work. Another thing that we weren't used to, again, being very file-based, is people weren't used to dealing with lots of services, lots of queues, and different things like that. They're like, well, what are we going to do about all this stuff? So we had to add some more support in that area. The other thing we learned is we learned a lot about DTC. I'm actually super excited about the new No DTC feature that's come out. We had to do some tricks when it came to some of the throughput on that original order management system. And if anyone's interested to hear about that, we could certainly talk after this about what we did to optimize some of the throughput on that. The other thing we learned is about the stack in and of itself is that original application was all .NET, all NServiceBus, built on top of Oracle. And again, with DTC and some of the other things that were going on, we ran into some couple of weird issues that we had to work around. And I think in retrospect, we would have just stayed all within that same stack, because everything we were doing up until that point, up until the database, was done in .NET on that Microsoft stack, except for the database. So I think in hindsight, we would have stuck a little more closer to that platform. All right, so what happened from there? So in all actuality, when people started hearing about what we were doing in the supply chain world, oddly enough, the marketing guys picked up on it, which is a little bizarre. We wouldn't expect that. So our second use case is more of a point-to-point type pattern, a point-to-point solution. The marketing guys wanted to develop a mobile application that would handle all of our marketing tools. So how do we show products to customers? How do we let them manage a shopping list, write reviews, do all those things? And along the right-hand side there, you'll see an example of our shopping list and how you can manage that into the app. You want to be able to show them their purchase history. And the reason that's cool is you can start building your shopping list off of purchases that you've made in the past. So a ton of tools we were trying to bake into this really small format. And not only that, again, we had millions of customers, and we figured, what the heck, how are we going to pull this off? The marketing guys wanted to make sure that the customer experience, was really great for us. That's what we feel is our differentiation in the marketplace. We really try to go above and beyond for our customers. A couple of weeks ago, Udi was over to visit, and he mentioned to me that he went in the bathroom, and in all of our bathrooms, especially, I'm assuming a lot of people are parents, there's like rows and rows of diapers and wipes and all these things in our bathrooms just to accommodate. We know that families are one of our biggest customers, so we always try to go above and beyond for our customers. So there's a lot of pressure here in order to build an app that's really solid. So the way we did that is a lot of the data behind these marketing tools was in a bunch of different places. So in order to accommodate that, we knew that doing a traditional completely request response system wasn't really going to be an option for us. It's, how are we going to pull all this together? We really shouldn't be making users wait to manipulate their shopping lists. If they write reviews, that's an important thing. They spend all this time writing the review, filling out the text, and then what if we lose it? We really didn't want to do that. So how do we get around that? The way we approach this is we decided to separate all of the reading that was going on of data in the application and all the writing. And I will say that this is not a true CQRS system. It's CQRS-like. But what that did for us is we were being able to optimize this whole view model. So essentially we put up a cache of all that marketing data. So we got pictures, we've got product nutritional information, we've got ratings, recipes that go along with those products. We've got tons and tons of data. I would say, the primary use case for this application is all of the reading kind of side of the data. And then the other side of that is really the writes in terms of manipulating your shopping list. You're writing a review. We want to ensure that that gets to the place that it needs to go. So the other challenge that we had with this, especially on the right side, is we have this really flaky database that houses all the shopping lists. And this thing, for whatever reason, would go down, it seems like, at least once a week. And I think the marketing folks really started to appreciate this when this particular database would fail. And we would say, hey, what's going to happen to everyone's shopping list? It's like, don't worry, we have the shopping list. People aren't going to lose them. We're still using some caching on the client side to make sure that they have their shopping list, and eventually they will get there. And this worked to our advantage. Trust me, it's several times, probably several hundred times. We have still yet to get rid of this thing. I really can't wait to do that. But again, by separating those two things out, we were able to handle kind of a dicey situation on the right side, and then really tune and optimize, all of the reads on the mobile side. So this has been a pretty good success for us. We got tons of customers using it. It actually even changed how we roll out Wi-Fi to our stores. Once people started using the app, we had always had guest Wi-Fi in our cafes. We call them our market cafes. And by implementing this mobile app, it really pushed us to start spreading Wi-Fi, have complete coverage all over the store. So I never would have thought that something like a mobile application would actually change some of the physical properties of our store, but that's actually what it did. So now that we're on the customer-facing side of things, there's another use case that I want to get through. We also have pharmacies in our stores. Very similar setup to the other mobile situation. This was not mobile. This is web. This is a portal. You can go in, look at your prescriptions, manage refills if you're a caregiver, manage prescriptions for other people. We have a big vendor off-site pharmacy platform. It's a kind of like an ERP for pharmacy. And again, in order to optimize the interaction with that, we split the reads and writes up using NServiceBus. But the interesting, the spin-off here is we were able to manage a lot of problems for customers ahead of time. So if something goes wrong with your refill, it's usually because a particular piece of data is missing or an approval is missing or something like that, something that we can take action on. So what we did is we managed our exceptions explicitly, and we were able to push those over into a customer care application where the service desk was able to help those customers before they even knew there was a problem. So again, another customer service thing that we can do for you is we know that your refill isn't going to happen for whatever reason. We can do something about that, so why don't we? So I really want to jump into this as another demo really quickly, and I will get the screen up there. I know I'm running short on time, but I think this is a scenario I was actually talking to some people yesterday about. how the heck would you do this? And this is just an example of what we did. So really quickly, again, basic client server setup. The main difference here is on the server side, we implemented our own custom fault manager. So how do you do that? So you implement this interface. I manage message failures. We also need to do a little initialization because we're injecting some classes into the container. We start out our custom fault manager with a default policy. So by default, it's just going to do the same thing for every type of exception out there. Again, some out-of-the-box properties. So this is where it gets a little bit interesting. The processing always fails for that message. So what we're taking over here is it's still going to do those first-level retries, but when it comes in here, it's going to come in and take a look at the policy that's configured. And we have a property here called ignore. So what is that? This ignore property is basically a list of exceptions that we can check against. So when we go and handle our exceptions, we check our ignore list. And in our case, for the pharmacy application, this was actually a slightly different thing. It wasn't ignore. We were looking for specific exceptions that we created that we could divert to our help desk. So this is slightly different, but it represents a similar thing. And we just check against that list and say, hey, if any of those exceptions match that, then hey, do something custom or do something different, let's say. So in order to do that, we have our own little sense of a policy here with our list. So made up an interface, have a custom version of that. In our custom version, we're ignoring argument exceptions. Work that into the container. Also make sure that our custom fault manager is in place. Fire this up. Now in my code, I'm explicitly throwing one of those exceptions. So what you should see is once that's sent, so this is one of the ones in the list. You can see it, it's retrying, doing that first level kind of bang, bang, bang. Here we go. So now, if this would move over, we get into our list. It's checking our policy. Hey, what kind of exception is this? It's one of the ones in our list. Basically, for now, we just print that out and move on with life. So that's how we got through and actually we're able to provide better value to our customers just by being smart with our exceptions and handling them in a custom way. So I'm going to jump all the way down to the end. Yes, you can see that. Perfect. So in summary, I didn't get to all the use cases, but a couple of things I really wanted to point out that I think work really well is we gained a ton of efficiency just by way the platform is put together. Someone was talking the other day about how easy it is to point a developer to a handler and say, hey, you just need to fill in these pieces, and then there's a little bit of communication out. The other thing that does by splitting that into those handlers is you can divvy up that work very efficiently. You can say, hey, this guy can go work on these 10 things, this guy can work on those 10 things, and then it's all going to be looped back together. So there's a huge amount of efficiency that we gained just by divvying up the work based on that. The other thing that it really gave to us is the sense of focus, and the reason being is that people love to reinvent the wheel. People love to do plumbing. I love to do plumbing work too, plumbing code. It's cool stuff, but when you have a piece of software that will take care of that plumbing for you and does a really good job of it, you can focus on business process. Again, divvying up those handlers is really, truly, you're getting down to writing business logic. You're not spending all your time worrying about how things get from point A to point B. And that was a huge benefit to us and a huge selling point. So with that, that's all I have today. If you guys want to hear more use cases that we have, because I didn't get to them all, please come up after the talk. Thank you.